See where I can see it, the water pumping out from under the ice sheet. Hi everyone, my name is Gavin Kenny. I'm a geologist at the Swedish Museum of Natural History.
Hello, I'm Will Hyde from the University of Copenhagen.
And this week we're on the west coast of Greenland, sampling sand and rocks that have come from under the Greenland ice sheet. Oh my goodness, wow.
We recently travelled to Greenland to collect samples from rivers flowing out from under the ice in an effort to find evidence for meteorite impacts underneath the ice. We know of at least one impact crater under the ice in Greenland, and judging from what we know elsewhere on the Earth, we think there must be more. So there's about 200 known impact craters on Earth, and the rocks in Greenland are quite old, which means will have had plenty of time to have accumulated impacts. Because impacts are relatively rare, but if you have old rocks, they will have accumulated some.
Quite a varied sand, we've got different grades, different compositions. And we'd hope somewhere in there there's key minerals that can show us what we're looking for.
The reason we're looking at sand samples from rivers is that the rivers are flowing out from under the ice, so they're sampling big area under the ice that we can't access any other way. And in the sand, so when an impact hits, it's extreme pressures and temperatures, and it affects the rocks in very specific ways. So if we find grains, we're trying to find grains that have these features. So they're very specific features that can only happen with extreme pressures and temperatures of that meteorite impact.
We're standing here at the edge of the ice. My colleague Will, background, is about to take a sand sample. So Will, what are you going to look for in the sand when you get back to Copenhagen?
So we're going to look for microscopic evidence of large meteorite impact craters. May exist under the ice sheet where we obviously can't see. So hopefully in here we have these small grains called zircons or quartz, and they might show evidence of the impact if it exists.
Great.
Now that we have the samples were brought back to Copenhagen, my colleague there, and probably next year bring the samples up to the museum and we'll search through them in the lab to find minerals that might have evidence of shock. So we'll separate out certain minerals that are of interest and see if these have features that show evidence that they've been hit by meteorite impact. So we think there's definitely, it'd be very surprising if there's not more impacts underneath the ice. And to try and find evidence for those, work out when they happened, that could really tell us a lot about impacts and asteroids hitting Earth.